All right, hello everyone, Aditya here, and today we're going to go over the ACT Science section. Now, this is typically your last required section for the ACT. That after this is the optional writing section, but this is typically your last main section, and we're going to break down exactly what the ACT Science test entails, go over some skills, then go over the different passages, and finally some personal tips on how to be successful in this section. So to start off with our breakdown, the ACT Science section is 40 questions in 35 minutes. So you have more questions than you have minutes. Remember that for this section. You have around 6 or 7 passages that have 5 to 7 questions in them. And the test is in a passage format. So you'll have to read almost like a reading comprehension passage, but it's a bit easier. And you might even have figures as well, which you will use to analyze and answer questions that are given to you in the section. We'll go over that in a little bit. Passages are on various science topics, so it can be like earth science, chemistry, biology, physics, any of that, anything in the scientific realm. And what's important is you do not need background knowledge to do well in this section. So you don't need to be a physics expert or a chemistry whiz to do good in this section. You just need to be able to understand the passage and understand the figures, especially the figures that the ACT is giving you, and you'll be able to do amazing in this section. So let's go over some important science terms first that every student should know for the ACT Science section. First is variables, right? What are variables? They're basically any factor that can change or is changed in an experiment, right? So we have two major types of variables that we're going to go over. We have the independent variable, which is the variable that we are changing. So for an example, if we have different types of fertilizer and we're trying to look at its effect on plant growth, right? Our independent variable, what we're changing, is the type of fertilizer. That's different for the plants. And a dependent variable, that's the variable we are measuring. That would be the plant growth in this case, because we're trying to look at how does type of fertilizer affect plant growth compared to normal plants. What's important for variables is that you only want to have one independent variable when you're doing an experiment, because if you have more than one variable that's changing, how do you know that the change in the dependent variable is because of the independent variable? It could be another factor or a combination of factors. So it's important to just have one independent variable that's changing. Everything else needs to be constant. And on the ACT, it's already ensured that there's one independent variable, so you don't need to worry about that. Trends are also pretty important for the ACT Science. There's two major ones that you need to know. Directly proportional. So as your independent variable increases, your dependent variable increases as well. So something like this, for example, right? Our independent variable is increasing, so is our dependent variable. It can work in the opposite direction as well, right? If we decrease our independent variable, our dependent variable decreases as well. They're going in the same direction. Inversely proportional is the exact opposite. As one increases, the other decreases. So as our independent variable decreases, our dependent variable increases, right? Like this. And vice versa as well. So those are the two major trends to know for sure. Then we have graphs. These are very important. You're going to see a lot of graphs as figures on the ACT Science section. So what's important to know for graphs? Typically your independent variable is going to be on your x-axis. So going back to our original example, right? Let's say we have our type of fertilizer, which I'm going to mark as F, right? And then we have the different types of fertilizer more specific here. That would be our x-axis, our independent variable, because that's what we're changing, the type of fertilizer for the plants. And our dependent variable, remember, was plant growth. I'll just mark it as PG. So plant growth, that's our dependent variable. It's on the y-axis, is what we're measuring. You can have multiple lines on a particular line graph. We'll see that in an example in the next slide. Typically, it's where you have multiple different types of samples or catalysts or something like that. It's specific to whatever the passage is when you see it on the ACT Science section. One major thing to know for graphs is there's really two ways you can read them. It's based off of points and slope. So we're going to go over slope first. Slope determines your relationship between variables if it's a linear relationship. So linear relationship, it means it's just a straight line. So if it's a positive slope, it's actually a pretty bad graph. If we look at a positive slope like this, right, as our independent variable increases, our dependent variable increases as well. It's positively sloped. It's not changing very fast. It's changing at the same rate. Our negative slope, it's very similar to an inversely proportional, just like how positive is directly, right? It's like this. As our independent variable decreases, our independent variable increases. And then no slope, that means that the independent variable has no effect on the dependent variable. It would be a straight line like this. No slope, there's no change with the independent variable on the dependent variable. And on the ACT, if you don't see a linear relationship, it's typically going to be exponential. So it will look like this. Typically, as your independent variable increases, your dependent variable is increasing at a faster rate than it would in a positively sloped relationship, for example, because here it's changing at the same rate, here it's increasing faster. So those are the major types of relationships you'll see. And in terms of points, it's just being able to read the independent variable and dependent variable at a particular point. So like, let's say we have 250 on the x-axis and 50 on the y-axis. This is just a hypothetical. And we want to figure out that point, right? So we'd go up here, right around here is where we'd find it. It's a little off. Let's say here is actually 50. And right here, this would be how it would be on the y-axis, and then this is how you'd measure it on the x-axis. This would be our 250 mark. Just a hypothetical. Being able to see a particular point and read it from the x and y-axis. That's also important to see from graphs. So we'll look at an example here. We have temperature on the x-axis as an independent variable, and we have thermal conductivity on the y-axis as a dependent variable. And this is what I meant by multiple graphs. Here we have different types of rocks, right? Rock salt, this is the top one, then granite, basalt is the solid line, and then shale is this very dotted line. So using what I talked about in the last slide, if we say, okay, an example question on the ACT could be at 200 degrees centigrade, which rock has the highest thermal conductivity? We'd go up and we'd see that, okay, right here, this is the highest thermal conductivity. So that would be rock salt because that's having the highest thermal conductivity at 200 degrees centigrade. It's also important to look at trends, right? If we see that the rock salt, right, what's the trend going on in the rock salt? We see that it's decreasing the entire way through. It's not linear, but it is decreasing. And it's important to note for trends on the ACT, it doesn't always have to be always decreasing or always increasing. Like if the thermal conductivity for rock salt actually went up like this from 200 on, you could say decreasing then increasing. That would be an answer choice on the exam. So it's not always decreasing or increasing. That's important to know. Now looking at tables, they reflect similar information as graphs, but they're numerical values, right, instead of lines or curves. Our first column is usually our independent variable. Our second is mainly our dependent variable. That's not always the case though. You can have multiple variables in a table. But what's really important with these is that you need to look at the relationship between variables, what each variable does compared to the others. So if you were to set one variable as your particular independent variable, how does it impact another variable, which would be your dependent variable in this case? So for an example, we have different variables here: energy per photon, relative intensity of light, electrical current, and maximum kinetic energy of the electron. And we see that we can have multiple independent variables here and check dependent variables, right? We can have energy per photon as an independent variable. How does that affect electrical current? How does relative intensity of light affect electrical current? But you can basically break down this table into three different subgroups of trials, right? One where it's all 2 energy per photon, one where it's all 4, and one where it's all 6. And what you can do then is, in a particular trial, holding this energy per photon constant, you can look at the relative intensity of light as your independent variable and say, okay, as we go from low to medium to high, how does that impact the electrical current? That would be our dependent variable. Or how does it affect our maximum kinetic energy of the electron? That would also be a dependent variable. So being able to read particular values from the table is important, but also being able to kind of hold certain variables constant and have ones take on the role of an independent dependent is also important. You'll get questions on that on the ACT as well. All right, sometimes you'll have variables in multiple tables. You're going to be given multiple tables and you might need to find the relationship between variables that are not in the same table. The one thing that's going to be in common with these tables is that you're going to have one variable that is the same in both tables. And you want to use that variable particularly to figure out the relation between other variables. And we're going to go over an example here to understand it better. So say we have a table for length and resistance, and we find that as length increases, resistance increases. Okay, so that's from the first table. We have our data, we figure out this is the relationship. And then our second table is looking at resistance and cross-sectional area. And we find as resistance increases, our cross-sectional area decreases. So now we're asked, what is the relationship between length and cross-sectional area? Well, resistance, that's the common variable in both tables, right? So we see that as resistance increases, length increases, and as resistance increases, cross-sectional area decreases. So now that we've held resistance in common and we have it in the same direction, this is important. It needs to be both resistance increasing in both tables or both resistance decreasing. So that way you'll be able to apply your relationship between length and cross-sectional area. So we see here, we can apply and say that it's length increasing as cross-sectional area decreasing, meaning it's an inversely proportional relationship, because as one variable increases, the other decreases. So you'll see that sometimes on the ACT Science section as well. So now we're going to go over the types of passages. You have three main types of passages you'll see on test day: data representation, research summaries, and conflicting viewpoints. So data representation passages, these are typically the more easier passages. They'll have charts and graphs. It is paramount you understand these charts and graphs, because a lot of questions in these passages are going to come from those figures. It's 2 or 3 passages for this section with about 6 questions each, so 12 to 18 questions in total, and it tests your ability to interpret and understand the information you are given. A lot of the time for these passages, the majority of the information is in the figure. Any information above in words is typically explaining the experiment or explaining the steps that created the graph or the table or whatever figure they give you. But the figure, that's where you're going to get the most amount of questions. So I have a practice passage here. I'm not going to go through it for time's sake. I know I'm a pretty long video so far. So what I want to focus on here is the table, right? You can skim through this passage really quick. It's basically explaining what's in the table, what's in the graph. So in the table, we have these subgroups, right? Subgroups of 3 groups of 4 where the pH is held constant. The nickel concentration assumes the role of an independent variable, and you have dry mass as your dependent variable for different species. So this would be your dependent variable for this table in this instance, if you were looking at subgroups of solutions. For the graph, we're looking at nickel concentration on the independent variable and average iron or zinc content as the dependent variable. And the key is also very important in a graph, because when you look at points, they might ask you, okay, at 10 micrometers, what would species M concentration of iron be? So that would be this line. You look right here and see, oh, it's 100 milligrams per gram. So just by these figures alone, we're going to go through and see how many questions deal with the figures to kind of emphasize how important it is to understand figures. All right, according to figure 1, all right, we already have a figure question in the first question. All right, table 1, another figure question. Table 1, another figure question. Table 1 and figure 1, another table question. Another figure question, another figure question. So every single question in this particular passage dealt with either the table or the graph. Figure 1 just means the graph one, we saw that. So based off of the questions that they're asking, some of them might require you to do a little bit more work, like this one, right? It's giving you ratios. So you look at the ratio of the dry mass of species U to the dry mass of species M, or ranking, for example. But you're still following the same idea. You're still looking at the table, looking at the figure for information, and then you're just doing an extra math step. So I'll pause on the passage here for a second if you guys want to pause the video and go through it. And I will go ahead and pause on the questions here if you guys want to go through it as well. And here would be the answers in case you're interested. All right, research summary passages. These are experiment passages now. There's several experiments with a lot of text and figures. You have 3 passages of these with about 7 questions. So that's 21 questions in total out of the 40 in this section. You need to understand not only figures here, but what is being manipulated in each experiment. You might have more diagrams that deal with experimental setup. You might have more text for you to read. These are typically your medium level passages. So here's an example. Again, I'm not going to go through the entire passage and questions for time's sake, but it's just important to look at the steps as well as the figures and what is changing in each experiment. So in this figure, we have temperature and number of cycles with different lines corresponding to different catalysts. And in experiment 2, we have pressure and amount of ammonia with different temperatures being our different lines in this case. Make sure to read these paragraphs here as well, because sometimes you might have to use both graphs, or you might, for example, here it says catalyst Z. So if you're asked to figure out the temperature at a particular NH3 and like how much NH3 is being produced, it's important to be able to look at both experiments and understand where they're getting this data from. So here are the questions. Again, a lot of figure ones, right? This can be answered from a figure. 21 can be answered from a figure. Same thing with 22. 23, that's where your steps come into play, where you read the experimental steps. 24, that's another figure question. 25, that's a figure question. 26, again, you're using the experimental steps. And then 27, this is one of those questions where, like I was talking about, you need to be able to use both figures. So I'll pause on the passage for a second. If you guys want to pause the video and go through it. And I will pause on the questions if you guys want to answer them. And if you have any questions at all, please don't hesitate to let me know. Here are the answers if you are interested. Again, in the interest of time, I'm not going through every single question. All right, in conflicting viewpoints passages, these are the toughest types of passages. It's an argument between 2 or more different viewpoints on a particular issue in a scientific community. It's one passage only with 7 questions, but you're probably going to take the most amount of time per passage on this one because it's a lot more words. There's not really figures. You need to understand the viewpoints and answer the questions. Typically, what's important is you want to try to understand the main points of what each scientist is saying, because typically you'll get questions that deal with just one scientist's perspective, or they might say, oh, we have this piece of data, what scientist's explanation does it strengthen or weaken? So it's important to kind of just read these passages slow, read these viewpoints slow, and understand, try to write what are the most important parts from it, and try to look at differences between the scientific passages. So I'll give you a second to read this and kind of jot down some thoughts about what exactly, just the main points of what each scientist is saying. And then here are the questions. So, right, I would answer questions that deal with a particular scientist alone first. So we have scientist 2 here. This is what I was talking about, where they give you a piece of data. Does it support or weaken a particular scientist's explanation? So these are the similar types of questions. Sometimes you'll have to compare perspectives as well. So that's always there. So I'll pause on the questions for you guys to go through it. And here are the answers if you are interested. So those are the main types of passages in the ACT Science section. I'm going to quickly go over some personal strategies for the science section itself. So always start with figure questions before reading comprehension questions. It's important to understand what the passage is saying in terms of if they're explaining what the graph is, or if it helps you get more information on an independent dependent variable. But figure questions, just reading the graph, reading the table, figuring out relationships, there are a lot of questions like that on the ACT Science section, so it's really going to help you. With graphs and tables, you're looking at relationships. Remember that. You want to try to do conflicting viewpoints last, just because it's the toughest one. It's a lot more reading, and I'd rather you guys get points in the other sections before going to conflicting viewpoints. Again, the more points you can get by doing graph and figure questions fast, the more time you're going to have for more reading comprehension questions. This is important. All answers should be found in the passage, or they're logical based on the passage. It should make sense based on the passage. So either you're getting it from a graph or a table, or it's making sense based on what the scientists are saying in the particular passage. And make sure to, of course, use process of elimination when needed if you're having difficulty with eliminating answers. So that was my overview of the ACT Science section. Thank you so much for watching, and I hope you will continue to follow me in going over the other sections of the ACT. Thank you.